Many believe that all interbody devices are the same and function only as a spacer during spinal fusion procedures. At Titan Spine, we strongly disagree. In fact, we feel that the implant should be an active participant in the fusion process. Through a proprietary surface treatment method, our titanium interbody devices are designed to do just that. Clinical success with interbody fusions is heavily dependent upon the initial host bone response to the device following implantation. This reaction is significantly affected by implant composition and surface topography. While a roughened macro texture is important for the initial purchase of the implant, it is the topography of the device at the microscopic and nano levels that play a crucial role in the bone formation response. While most implant materials such as metal, ceramic, and PEEK are smooth at the cellular level, the Titan Spine surface incorporates textures on a scale that elicits a superior osteogenic response. One of the first events to occur following implantation is the recruitment of mesenchymal stem cells to the site. The surface energy and microtopography of PEEK causes the stem cells to flatten on the surface of the implant and primarily differentiate into fibroblasts, a type of cell that produces different forms of elastic collagen fibers. As a result, the PEEK implant is eventually encapsulated in a membrane that predominantly consists of fibrous tissue, which reduces the amount of bone available for fusion. In contrast, Titan Spine has engineered the surface of its titanium implants to have the ideal surface energy and microtopography to promote the differentiation of mesenchymal stem cells into bone-forming cells, called osteoblasts. In addition to local bone production, these osteoblasts produce signals that are received by other cells in the area to begin making bone. This early attachment and signaling activity is an essential step in the bone formation and fusion healing process. Once this has started, the Titan Spine surface stimulates local production of bone morphogenetic proteins, or BMPs, which are the cell's natural promoters of bone growth. The surface textures prompt the BMPs to be generated in the appropriate amount and at the correct time in the healing cascade to further drive the fusion process forward. Over the course of a few weeks, one can see that the Titan Spine endoskeleton surface stimulates a superior osseous integration response when compared to PEEK polymers, thus creating the potential for a faster and more robust fusion. It is time to start demanding more from your interbody device.